what is going to be, this is 3/6 to beta less, okay? And we already covered this problem with you on Monday. And this problem said this. What's the derivative of the tangent of 4x? And that's 3/5. You see how this is scaffold? The derivative of the tangent is secant squared. So your natural inclination, here's the problem, ready? It's a multiple choice question. What would happen? Oh, it's secant squared. I go to D and I read secant squared input answer without reading all the choices. That'd be good. You need to read all the choices before you decide what's correct. Because D's not correct. Because the issue is, if the question were y equals tan x, then dy dx equals secant squared x times 1 times the derivative what's inside the parentheses. But you never notice that one because it's the identity element of multiplication. You're still doing the chain rule. So in here, the derivative of what's inside the parentheses isn't 1. It's a 4. So your answer is not D, it's 4 times D, which is D. And we did that on Monday. And, oh, I'm sorry, you did it at home on Tuesday. You did it at home on Tuesday. You had a chance yesterday to do some work in a work day and to hopefully reinforce it. So the first thing we're doing today is example number 5. I'm in the textbook on page 150. What I want to do today, the end of the period, get the book. I'm writing myself a note. If you took the book, I want to write the book number so it's easier for us to get them. But that'll be when we're done. Now, in example 5, there's 3 links in the chain. It's the chain rule, but you have to apply it twice. If you look at the question, ready? I didn't rewrite the question up here. You want to go do the problem inside out. So I bring up the textbook. I didn't write the question. You want the derivative of this mess. You have a composite function. But really what you have is this. You have the tangent of this thing. And the tangent of 5 take away sine 2t involves a composite function because you have the sine of t and the sine of 2t. So when you work inside out, and you start with the 2t and go out, you would literally work from right to left. Now, I don't really have a handle yet because I'm not collecting people's work about who's organized with their work and who's a little sloppy, and got to be careful with this work. Because if you're disorganized, it's really easy to get confused. The most inside part of this thing is 2t. I want to call that D. It doesn't matter what letters you call. But here's the dimensional analysis where the D mu's reduced and the dB's reduced. That's the 3 links to the chain. You could have 10 links to the chain. The reality is most of the problems you're going to do in May that involve the chain rule would not even involve 3 links to the chain. This is confirming you understand what's going on. So then what's inside the parentheses is 5 take away the sine of that 2t. So we're going to call that we already called that D. And the big graph is tangent of everything inside of it. So then you just, from this line, this is the problem right here. You can write this line pretty much done. Because from there, you are doing what? You are differentiating vertically. So this suspected t differentiates to 2. This suspected b, right? Derivative of 5 is a 0. Derivative of sine cosine, subtract sine, just subtract cosine. Derivative of tan secant squared. So I look up here. It's just going to be this times this times this. Except you can't leave a u or a v in your answer because you introduce them to the problem. So when you look in the book, it's kind of messy. If you look in the book, you get this answer way down here. But all that is the product of those 3 derivatives that we calculated. This answer is just the 3 derivatives where you didn't have a u or a v in your answer because it wasn't in the question. Your final answer, ready? In the textbook, you find it look. -2 secant squared u. Secant squared what u equals, which is -2 secant squared 5 take away sine 2t. Here's the meter right up here. 5 take away sine 2t, right? Times that cosine. You factor that to -2. So that's up there. That's your model. You're going to problem 23. Go ahead. We're going to resume the recording, and here's what you have. This time I did write the question on PDF. We go to the very inside of this thing. The most inside thing in the parentheses is 7x. So I called that V. Right? Then what? What's being cubed? 1 plus cosine squared 7x, which I wrote as 1 plus cosine squared V. And the outside function would be u cubed. It doesn't matter what letters you use. But we want, ready, in this problem, what you're asked to do is find the derivative of y with respect to x. And the way we did this is we introduced these other letters. We said, all right, that's going to be equal to the derivative of y with respect to u times the derivative of u with respect to v times the derivative of v with respect to x. Those would reduce. And we would get what we wanted by dimensional analysis. And all we have to do is multiply the 3 factors together. So we go here. Differentiate vertically. 7x differentiates to 7 with respect to x. This is 0. Derivative of 1, 0. Now I got cosine squared. So cosine squared is cosine times cosine. So we're going to do the product rule. We would have cosine times, it would be cosine, it would be this, right? I want the derivative, in this case with respect to v, of cosine squared v. So that means the derivative with respect to v of cosine v cosine v. So I take the first cosine, I multiply it by the derivative of the second one. So I would get cosine times negative sine. Plus I take the second cosine derivative, multiply by the derivative of the first. It's also negative sine. So you have the same thing added to itself. They're both negatives. You have -2 cosine v sine v. That's the most work. This differentiates to just 3 mu squared. So this dimensional analysis is this. You need to write this out probably through next Thursday when you're taking or Friday when you're taking harmonic quiz. Then once you get the hang of this, you'll use the chain rule all the time. If you're not where we are right now today, I don't know what to tell you. This is the middle of October. We are going to leave you in the dust from the chain rule. You're going to use that every day. There's not something you don't see up there. You need to ask about it. So I just multiplied this times this times this. Except what? I can't write a mu in my answer because I introduced it. I can't leave a v in my answer. We introduced it. So I just say this thing here. See this line? This time, this, right there. Then from here to here, where there's a mu, I wrote 1 plus cosine squared, and I write v. Times this, where there's a v, I wrote 7x times 7. This answer is 100% correct. The only thing that happens between there and there is we multiply the coefficients together. So, like I said, I don't know. I don't expect you would see this often in May. But if you can do this with 3 links in a chain, you're good with everything up till right now. You can have 10 links in a chain, but it would just be busy work. Go to page. Now, people are writing stuff down. I want to give them a chance to finish what they're writing. The point is, you have access to the PDF. I get it. That some people are 15 seconds behind me. Some people are a minute behind me. You got to stay with me, though. We need the problem because you can come back to this. That PDF is in Canvas. This is another question. Example number 6. In example 6, you've got this curve, this blue curve, which is not a function. You see it fails the vertical line test, but it still has a slope. So we're going to go to parametric mode, try and calculate the slope, and actually the equation of this red tangent line. So we've done this multiple times, okay? If I go back and say, well, what is going on here? But this, what if I just compared this to x, y equals x squared, dy dx equals 2x. If I put a 3 in here, I get a 9, slope of 6. That's derivative of 6. Which means what? The parent graph of the tangent line is y equals 6x. And I'm going to slide that to the curve. So I'm going to slide it 3 units to the right of 9. By doing the opposite. And I would get y take away 9 equals 6 times x take away 3. Yes, we've done that. That should make sense to you. And all we're doing is the same thing, except we don't have a function. This has to be graphed in parametric mode. But the process is consistent. So what do they tell you? X equals secant t and y equals tan t. And they put a restriction on the domain. So we wrote it this way. Well, let me just show you this. This is more dimensional analysis. What I want is dy dx. So what I'm going to get that is find dy dt and divide it by dx dt. And the dt's would reduce out. Given x equals secant t. The derivative of the output x with respect to the input t is secant t tan t. Section 3.5. Y equals tan t. The derivative of y with respect to t is secant squared t. far, so good? So now what? I want dy dx. So I take dy dt divided by dx dt. Secant squared, secant, secant. The x dt, secant tan. They reduce. So I'm going to rewrite these functions. I rewrite secant as 1 over cosine. I rewrite tan as sine over cosine. These cosines reduce. Like if you were to invert and multiply, yes, we understand that. Like you have this, literally. I know that that's kind of abbreviated. You have 1 over cosine t divided by sine t over cosine t. So in effect, what are you doing? You're inverting and multiplying. Why? Because if I multiply this by its reciprocal, cosine t over sine t, cosine t over sine t, everything here in this box is equal to 1 because it's something divided by itself. When you multiply across, so the denominator becomes 1. So what's the shortcut? The shortcut is invert and multiply. Where does it get you? They reduce and you get 1 over sine. If I didn't write that out, I'd say these reduce, you get 1 over sine, which is cosecant. What is cosecant? It is the reciprocal of the sine. And what did they tell you? They gave you pi over 4. Here's my circle. Pi over 4. What do you got? Yes, I had to do this. Pi over 4. Pi over 4. You get root 2 over 2. Root 2 over 2. Here's the sine. The cosecant is the reciprocal. So you would get 2 over root 2. 2 over root 2. That's 100% correct if you leave it like that. But if you want to rationalize the denominator, you multiply it by root 2 over itself. They reduce. And where you get 2 root 2 over 2. They reduce and get a 2. Now what? Now we're back over here. That's the slope. That's the slope. What's my shift? I go back to the original question and I put pi over 4 in for x, pi over 4 in for y. Pi over 4. Same thing, secant. Secant is 1 over the sine. That'd be 2 over root 2. That's giving you the x is root 2. What's this? I'm sorry, the function. See, the tangent. Tangent of pi over 4 is a 1. I think, are the points in there? The points are in the text, but you don't need them. You can calculate. So in the book, it tells you root 2 to the right up 1. Here's my slope. We go to the work, we get the slope. Shift it. Root 2 to the right up 1. Root 2 times x subtract root 2. This root 2 is the slope. This root 2 is your horizontal slope. It would be better if they had different numbers, but they don't. Up 1. Why take away 1? Done. That is the equation. If you look in the book of this red tangent line, this equation down here, just leave it like this, just like this. That's the way we left it. That's the equation of that red line. The parent graph is root 2x for the tangent line, which goes to the origin. You have to click and drag it so it hits the curve once. Yes, I see some people nodding their heads. It's terrible. But the point is, all you're doing is this. When you're stuck with this, you go back to some user-friendly problem and you build an H chart. And all you're doing is the same work, except you have a more involved, you have a parametric equation. parametric curve. So leave this up here, and you're going to problem number 41, please. Okay, so 41. X is 2 cosine t. The derivative of that would be negative sine t. Negative 2 sine t. Somebody asked about this. Make sure you understand. You have x equals 2 cosine t. Why is that 2 end up in the derivative? Well, because if you use the product rule, which you don't need to, you would get this. Dx dt equals 2 times the derivative of cosine, which is negative sine, plus the derivative of 2, which is 0, times cosine t. So you would just get negative 2 sine t. The derivative of 2 sine t is 2 cosine t. I want dy dx. So it's dy dt over this. 2 is reduced, you get a negative. Cosine over sine is negative cotangent, which is the reciprocal of tangent. In a pi over 4, the tangent's 1. The reciprocal of 1 is 1. So the slope would be a negative 1. Then what? Well, at pi over 4, the sine and cosine are both root 2 over 2. And you have a size change of magnitude 2 to that. So the input and output are going to both be root 2. So that's the magnitude of this slide. The slope's negative 1. You would end up with that.
Are we supposed to simplify the last further?
I wouldn't. You can if you want. Ready? This is 100% correct in May. I prefer this. I prefer looking like that so you can identify the magnitude of the slide. In order to put it in your calculator, yeah, you got to add root 2 to both sides. But the calculator doesn't know if it's in y-intercept form. Okay?
At the first step, when you have like the 2 cosine t, how come you don't, the 2 doesn't turn into a 0? Like you not take the derivative?
Yes. Ready? It's 2 cosine t. It's 2 times that.
Oh, okay.
So the derivative would be the first term times the second term, plus the derivative of 2, which is 0, times that term. So you would get this much of it.
Oh, okay.
Okay? You don't, going forward, you don't write that out. Just say, oh, bring in the coefficient. That's part of the answer.
Because I mean, I got the same answer, but I thought that it was just you're supposed to take the derivative of 2, so it was 0, but they cancel out in the problem anyway.
Correct. They reduce in this step here. Well, we didn't know that they reduced, right? Because it did have to be 2s on both. So one thing left. Does you see this? Here is example 7. But think about what this means. It makes the problem way easier. What did we do before? We did the derivative of cosine squared by making it cosine times cosine. So look at this. If I want the derivative of sine to the 5th of x, you can make sine x your mu. So the derivative would be 5 mu to the 4th times the derivative of what's inside. So you would get 5 sine to the 4th x times the derivative of sine to cosine. You don't have to write out the 5 factors. So the problem we had before was cosine squared. We wanted the derivative with respect to x, cosine squared x. We wrote it out as cosine times cosine. Now we can say it would just be 2 cosine x to the first times the derivative of cosine, which is negative sine, which is more efficient to do it. Okay? You can use the product rule, it's just it won't be efficient. So